So good morning, everybody. I want to talk to you about something completely different. And when I say it's completely different, you'll find out why soon. The reason why you have long queues at airports is because you're scanning for explosives, drugs, and contrabands. Koniku is the world's first wetware company. We're a very deep tech company, and you'll find out why soon. Now, the most advanced technology on this planet for figuring out if somebody is carrying explosives, drugs, or what have you, belongs to the dog. Lucky for us, Mother Nature doesn't have a lawyer because we're about to steal that technology. Now, how does this work? Inside the nose of a dog, there are little things called receptors. That's the magic. These receptors are so powerful. They are 300 times more powerful than the average receptor in your nose. Turns out, our species has figured out a way to actually harness this. So this receptor is actually encoded by DNA. On the top left-hand corner there, that is the actual picture of a receptor. This receptor comes in contact with an explosive particle. That particle generates a message in the nose of the dog, which is transported to the brain of the dog. This is what you're asking the dog. Now, imagine if you could spread that technology all around your airport. What we do is we take the DNA that encodes for that receptor, we stick that DNA in a neuron, in a brain cell. Brain cells communicate with electrical signals. We listen to those electrical signals, and we can tell you, without your customers divesting anything on their body, because they have an aura of smell around them. This is what we pick up. It's completely contactless. And imagine your passengers traveling through the entire length of your airport, from curbside to the aircraft, without touching them once. This is what your industry needs to evolve into. This is the iPhone of aviation. How do we reach this? So you have these receptors on the surface of the cell. We have developed a patented electrode that allows us to listen very closely to each individual neuron. So essentially, we go into the nose of the dog instead of you having to ask the dog the question. The signal resolution we're able to get from this is 50 times better than anything that exists on the planet today. And we have the devices to prove it. Right in the middle there, you can see a neuron responding to particles of chemical. And on the right-hand side there, you see the actual lab device. On the left, you see the neuron being connected to the electrodes that I mentioned earlier, and on the bottom right, you see the signal in full play. Like I said, our vision is to travel from the curbside to the aircraft completely contactless. You don't have to give your bag to anybody. Nobody has to touch you. You just walk through, and we can detect whatever it is you have come across. 72, 48 hours, it doesn't matter. So long as a dog can detect it, we can detect it. We're a wetware company. So on the left-hand side there, you see the picture of our chip. We open up this platform to a lot of developers to develop secondary devices on top of it. And these devices, of course, they have consumables. Now, the leading supplier of such equipment is Smiths Detection. Their device doesn't even come close. Here is the team. I have an amazing team. They are all here in that room. I encourage you to talk to very brilliant guys. There's John Charles Neal on the left there. He's a postdoc from UCSF. Christian Herold, a postdoc from Berkeley. Winston Mann, he's a machine learning expert. He's also there. And Suresh Ranjba, he develops the membrane technology that allows our devices to function. Our technical advisory board is led by the CEO of the Paul Allen Brain Institute. This is the Brain Institute that was founded by the co-founder of Microsoft, Dr. Simon Schultz. He was my doctoral thesis supervisor at Imperial College in London. We closed our Series A fundraise. We've raised more than $2.6 million to date. Our pilots already start by summer of next year. So we are keen to speak to all the airports in this room and begin to pilot our technology within your airports. Thank you very much.